Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 20th of December daily LeetCode challenge and we have a hard question on the topic of DP, that is dynamic programming. Let us see what this question is. So as you can see, we are given a integer array as the input and a integer k, and then we'll have to return a integer array as the output. Okay. Now let us see what this question is. So it is 689 maximum sum of three non-overlapping subarrays. So given an integer nums and an integer k, find three non-overlapping subarrays of length k with maximum sum and return them. So I hope assuming that you are now understanding the question. So we are given this nums array, which is integer array, and we are given a value k. This value, which is k, is telling us like what should be the length of the subarray. Okay, that remember it has to be non-overlapping subarray. So they are saying find the three. Remember, three is fixed here. Okay, three is fixed here. This is part of the question. It's not a variable here. Okay, this k will tell me the length of the subarray. Okay, we have to find three such subarrays. Find three non-overlapping subarrays of length k with maximum sum and return them. Okay, return the result as a list of indices representing the starting position. Okay, return the result as a list of indices representing the starting position for each interval which is zero indexed. Okay, we have to return the answer in a zero indexed way. If there are multiple answers, return the lexicographically smallest one. Okay, now see, let us see what the question is. So one thing is very clear. See, always we'll have to return the starting point of three surveys. So the length of the answer is always going to be three. That is one thing is very clear. Same is now coming to k. So if you see the constraints here, k is going to be around. Let's see this. The length of the array is going to be around 10 power 4, 2 into 10 power 4, and the nums of I is always going to be positive. Okay. Now, so first thing that will come to your mind is like uh, they'll see, clearly they're asking three surveys, and we'll have to take them in such a way that we are having the maximum sum. That is the sum of all the elements in that each of the surveys together. Let us all three of them, if you take them together, you are going to get a maximum sum. Okay, now you will tell me like why not to do that. Let us say we fall can't, like we go through the maximum elements. Okay, we'll try to capture the maximum elements in one of the subarrays, and then the next maximum element in next subarrays, and so on. But the idea here is that logic will not work because here the combinations also matter. We'll have to take them. Remember, it doesn't have to take only single subarray, but there are three subarrays, so we have to take them in such a way that the sum, okay, that is the elements captured by all three of them. If you take the sum of them, it is going to be the greatest possible. It is going to the max possible. Okay, that is the basic idea. The approach that I am trying to tell you is that I will be showing you the three-pointer approach here. So what is the three-pointer approach? See, it's going to be very simple. The see first time see. I hope you are clear with the question now. Always it has to be non-overlapping subarray. At the same time, the length has to be k. That is, length is fixed. It cannot be less than or greater than that. Remember that part. So see, one thing is clear. If we finalize, for example, see here, the see this I'm talking about the middle subarray. Okay, there are three subarrays going to be. First one is going to be the left subarray, the right subarray, and the middle one. Okay, so I'm currently talking about the middle one. This three-point approach totally revolves around the topic of the middle subarray. Okay, for example, see here, if I take this as my middle subarray, so only there is one option for my left subarray. What is that? This is the option for my left subarray. So this is the option for my middle subarray, and coming to the right subarray, right subarray could be any one of these. Among these four, I can take them in any order. Okay, as simple as that. There are multiple options for that. So the idea here is I am going to capture, see, I'm going to consider all the possible middle subarrays. Okay, for example, this 1 and 2, then this 2 and 6. Okay, and this 6 and 7. Okay, and this, okay, yeah, 6 and 7 is the last one. Okay, beyond 6 and 7, we cannot go, remember that, because the right subarray also has to be a length of 2. Okay, clearly the length is 2, right? So these are some of the positions, okay, where we can take our middle subarray. So what I'm going to do is, see here, so yeah, I'm just going to go through all the middle subarrays, and for each of these middle subarrays, I'm going to find the best possible left subarray and the best possible right subarray. Okay, that is for each of the indices of from where the middle subarray can start. For each of those indices, I'm going to find a best possible index to start the left subarray and the best possible index to start the right subarray. Okay, that is going to be my approach. So let us see how it going to work. So first of all, like since here we are we're dealing with subarrays and we have to take the sum. So the best idea that can come to our mind is having the prefix sum. Okay, once we have the prefix sum, we can always find what is the sum of the elements in that subarray is going to be. Remember, k could be bigger as well. For that reason, it's not a good idea to calculate them always. That is not a good idea. It will increase the time complexity also. So it's always better to have a prefix sum so that you can simply subtract the prefix sum of two different indices and get the number of the sum of the elements between them, those indices. Okay. So first of all, I'm going to maintain a prefix sum. So this is how the prefix sum is being maintained. Here, all the elements will be having zero initially, and remember, I'm taking a length of n plus one. Okay, n plus 1. Why? Because the idea here is we'll have to take one more element compared to the elements given here, so that the element of the all the sub, that the whole subarray is also maintained. Okay, that is the basic idea. Fine. I'm printing this basically to show you. Okay, let me show you that how it looks. So yeah, the first one is going to prefix summary. As you can see, this is the total number of elements. If you see, we're having one more than that. Okay, here the last value is going to tell me the sum of all the numbers. Okay, that is the reason why we have kept n plus one as the length of the prefix sum. Okay, this is only for this. Rest of that is we're going to have exactly n elements only. Fine. Then what is the next one? After that, we are going to create two new variables. What is that? Left max index and the right max index. Okay, initially we will be initiating them with -1. Okay, initially all of them will be having -1. Why? Like you will ask me, here we took 0 as the default element, but here we are taking -1. Remember, even 0 is a valid index, right? For that reason we have to keep -1 to show that there is no valid answer for this, that is no valid left max index for this particular location. Okay, that is the reason why we are doing that. I will tell you how it works basically. Okay, let me show you that first. So if you see, this is the array given to us, okay, and this is the left max index array, okay, given to us. Now as you can see here, see this part. First of all, this what I'm highlighting in the screen currently, that is going to be the first mid, okay, mid sub array, because mid sub array cannot start from this index, okay, because in the left of that mid sub array there has to be a left sub array, right? For that reason, this is the first position from where the mid sub array can start, okay. So the index of this particular one is going to be the first index onwards from where our array can start. So that is the reason why if you see in the left max index array, if you see, we are starting populating values from this index onwards. Okay, prior to that, all the elements are having a value of -1. Okay, do you agree with me in that? Okay, fine. Now, if you see to where it can go, for example, now see here, this particular 6. Okay, if I start a subarray in this particular 6, that is I'm talking about this particular subarray. This is going to the last mid subarray. Okay, because after that I have to leave space for the right subarray. Okay, so if you see the index for this, okay, 0 1 2 3 4. Okay, the index 4 is going to be the last array from where, yeah, this, as you can see here, this is the one. After that, all the values of them will be -1. Remember, in the both left max index and the right max index, these indexes will be -1 only. Okay, as simple as that. Now if you tell me like what is the zero meaning here, zero means that, for example, let us see here, let us say I am at this particular, let me explain this part. Okay, it is 0 1 2 3 is the index 3, 0 1 2 3, yeah, index 3. Okay, now if I start a subarray like this, okay, this is going to the mid subarray. Okay, now what is the best possible left subarray for this? Remember, we also have to consider one thing, that is the lexicographical smallest one. That the idea here is, if we're able to get multiple subarrays, okay, with the same sum, we should take the one which starts at the earliest. Okay, so I'm currently at this particular position, 2 and 6. So can you tell me quickly, in the left of it, what is the best subarray to take? See, I am going to take this as the subarray for this subarray which is going to start at this. Why? Because if you see all the subarrays, okay, for example, 2 and 1 is also giving sum of 3, and 1 and 2 is also giving sum of 3. So it's always better to take the one which is starting from the smallest possible index. So that is the reason why 1 and 2 will be the most ideal subarray, left subarray for 2 and 6. For that reason, we are keeping this as the 0. That it will tell me what is the index at which the left subarray should start. What is the best possible index at which the left subarray should start in order to give us the maximum sum. Okay. So as you can see, for this also and for this also, the answer is going to be same. Now coming to the right max index, this array will tell me, like for this particular, if I start a, you know, if I start the mid subarray in this particular index, what is the index? 0 1 and 2. So this is the second. Okay, for example, this, if this is the mid subarray, okay, then what is the best possible index to start the right subarray? Okay, this they are telling is 4. Okay, what is 4, by the way? So let us see, 0 1. Yeah, so this is the mid subarray, 0 1 2 3, and this is the one. Okay, 6 and 7. So they are saying if this is the mid, then 6 and 7 is going to be the best possible subarray at the right. Okay, the right subarray. That is what they're trying to tell. Now let us say this part. Okay, yeah, this part, it is 0 1 2 and 3, 0 1 2 and 3. Yeah, this layer talking about this. If this is the mid subarray, okay, then if you see what is the value for that, the value for that is 5. They're saying the right subarray, then in that is 5.5. What is the 5? Basically, this is the going to the 5. Okay, yeah, this is the 5. So if 2 and 6 are the mid subarray, and then 7 and 5 is going to be the right subarray for that. So the idea here is, for each index, basically we are already calculating it. If we are going to start the mid subarray in this particular position, then what is the best possible right and left subarray for this position? We're already calculating them. Let us see how that is being done. So initially, as you can see, all of them are -1. Then now see, initially the result is also 0 0 0. Then this is the part where we are calculating the best left subarray position. How to do that? First of all, for the first subarray, for example, I'll see this part. This is going to the first mid array, right? Beyond that, that is left of it. We cannot start the mid subarray. So for this, always there will be only one option. Okay, this is the only one option present for this mid array. Okay, so this is the only left subarray possible for the mid subarray. Okay, for that reason, for the first one, always the default value will be like this. Okay, 0. Fine. After that, we will maintain the sum of it. Okay, the max left subarray sum seen till now. Okay, so this will be the prefix sum. Okay, because remember, prefix sum, why I'm taking directly without subtracting anything. Prefix sum basically means the sum of these two. Okay, I don't have to subtract it from anything because the left of it there is no such elements. Okay, so for that reason I'm directly taking the prefix sum without subtracting from anyone. Okay, as simple as that. Now I'm starting this from k plus 1. Remember, these things are very carefully chosen so that, because see, it should start from this portion onwards. Okay, that's what I'm trying to tell you. It should start from this portion onwards. See, these things are very carefully chosen. When I give the suggestion to in the comment section, go through it and try to understand why it is happening. Okay, as simple as that. Because as I mentioned, like otherwise, if you see the values will be -1. So those values we cannot find the max left position. Okay, for that reason they're -1. So we are going to start on this index onwards. Okay, for that reason, this particular loop, if you see, it starts from k plus 1 onwards. Okay, as simple as that. So for each portion, what you have to do, first of all, remember, whenever we are moving one position, we'll have to calculate the exact immediate subarray which is what is left. Okay, for that we are going to do this and get this sum. Okay, for example, if you see, if I talk about this particular subarray, so what is the exact left subarray? The exact left subarray is going to be this. Okay, so I'm going to calculate the sum for this, and then you have to compare. Okay, so it is first calculating the exact left subarray sum. Okay, and then it is comparing with the max left subarray sum seen till now. Okay, if this thing is greater than the max subarray sum till now, what we have to do? Now we are sure what is the index to which we should start the left subarray. Okay, and then we have to update this value. Okay, we have to update this value also. Otherwise, if this condition is not true, that means the exact left subarray to the exact left subarray which you are having for the current mid array is not the optimal one. In that case, what you have to do, simply take the index which we had for the previous left max index. That is, this is I, so take the value for the I minus 1. Okay, as simple as that. Okay, then I'm printing the left max index, and the same thing we are going to do for the right survey also. But remember, the only difference is for the left we started from k plus 1 and went till the last. Okay, here we are going to do in the reverse way. Okay, here we are going to do in the reverse. We are going to start from n minus this thing, and we are going to go till k minus 1. Okay, this is just the reverse. For example, if you see here, we started at this index and then kept moving to get these values. But the right case, for the right max index, we are going to start from here and then move toward the left. Okay, as similar. That is the only difference here. Okay, same as like the case of the previous one, left one. Here for the first one, that is, if you see the case of this, yeah, this case, there is only one subarray towards his right, so that is going to be the default one. For that reason, there is no comparison needed. You can directly populate that value here. Okay, and then take the sum of it, call it as the max right sub array sum till now. Okay, seen till now. Then we are going to go through each of the subarrays. We are going to calculate the sum of the elements captured for the exact right subarray. For that, we are going to compare it with the max subarray sum till now. Okay, if that is greater than this, okay, that is, if this is greater than this, what we have to do, that is the exact right subarray, what is the index, that is going to be our value for this. Okay, we have to update this also. If that is not the case, whatever was the value for the previous index, take that and simply copy it here. Then we are printing this part. You can go through it. Now start the real calculation part. Okay, till now we are only calculating the helping ones. Okay, now we are going to the actual calculation. Now that is our mid. Remember, this part is now going to tell me where the mid subarray is going to start. Okay, this is going to be that part. Okay, so I'm simply creating a variable called maximum. I'm initializing with 0. This is going to, that here, this I is going to tell me from which index my mid should start from. Okay, now the max index to start the left subarray, I'm simply going to take the value of this. Similarly, the max index to start the right subarray, I'm going to take the value of this in the right max index array, and this is the left max index array. Okay, I'm just going to the ith value of that, and this is going to tell me the index in which the left array should start and the right array should start, if the mid starts from this particular index. Okay, as simple as that. Now I'm going to calculate the sum of all the arrays involved. That is, the elements enclosed in the left subarray, the elements enclosed in the right subarray, and the elements enclosed in the mid subarray. Okay, this is the one for the mid subarray. I plus k minus this prefix sum I plus k minus prefix sum of I. Similarly, same part, prefix sum of best index to start the left subarray plus k minus prefix sum of best index to start left subarray. Same is the case for this, prefix sum of best index to start the right subarray plus k minus prefix sum of best index to start the right subarray. This will tell me the total sum. If, okay, this is the total sum. If total sum is greater than the maximum, remember the maximum is 0 initially. If that is greater than the maximum, what you have to do, result is equal to this. Okay, this is going to be the final result that we are going to have. Okay, what is this? That's the index to start the left subarray, this is the index to start the mid subarray, and this is the index to start the right subarray, right? Then we are going to update the maximum. Only if it is greater, remember that we are doing. If it is equal, we are not doing that. Can you quickly tell me why? The idea here is we have to return the lexicographically smallest result. For that reason, we are not including the equal to sign here. Remember that part, okay? And finally, this will keep continuing. After we come out of this particular for loop, we are going to return the result. So if you talk about the space and time complexity of this, remember we are using multiple arrays, but all of them are having only n length, okay? So space complexity is going to be O of n, and if you talk about the time complexity, obviously it is going to be O of n only, okay? But we are not doing anything more than that. So and finally we return the result. So let me quickly run this and show it to you. As you can see, I've already submitted the solution and it is clearing most of the test cases. This was a hard question. There are other multiple ways to do the same, but I felt this is going to be the most logical approach to do this because this really makes sense. We're not doing any extra or additional calculations which are not needed here. Okay, we are doing exactly what is needed and the bare minimum which is needed. So for that reason, I wanted to show this kind of solution. So I and that was all for this video. I am giving this code in the comment section. Take it. I've kept the print statements open. You can, while you are submitting, just comment these print statements so that you don't get the output limit exceeded error. So and that was all for this video. This was a really nice question according to me. And remember, this is one of those questions within the, remember, the first 1,000 questions of LeetCode are called the golden questions. This is one among them. Okay, especially the hard questions among the first 1,000 questions. They are really really great. So if you get time, sometimes go through them. They are really really great. This is one among them. That's why I felt like showing it to you. I showed you the solution which I felt is the most appropriate one. Okay, there are some multiple ways to do it, but remember, in the interview it's not only about getting the answer, it's also about your thinking capacity. Otherwise they will feel that you have already remembered the solution and you're simply copying it from somewhere else. But if you go with the approach, this approach, according to me, if you draw in a pen and paper and show it to them, this will make more sense to you. Okay, more sense to the interviewer. That's why, first of all, show this kind of in a pen and paper, show them to you, show them the approach you are going to have, and then start coding. I'm sure that this will be creating a best impact on their minds for you. So yeah, that was all for this. And if you like my efforts, please subscribe to the channel. This really gives us a lot of motivation to continue further. Happy Christmas to all of you, and at the same time, in advance, Happy New Year to all of you. See you tomorrow. Thanks a lot.